Today we're going to have a lecture and a series of lab exercises, demonstrations, and then you need to make progress for your final project, okay, in order to finish your final project on schedule. So we're going to have a lecture and lab exercises. But actually the most important thing is final project development. We discussed one by one or with your friends what you're going to do for the final project. But anyway, from now on, we need to make kind of intensive progress for your final. Anyway, kind of assignment, homework on intensive progress report next week. Okay, that's one of the most important today's lab exercise. Okay, let me show you the case study first. Let me show you one case. This is an actual project currently me and my research assistant students are working on. Okay, let me introduce a beam-enabled design approach. Okay, as a real actual case. So take a look this one. This is kind of remodeling or reconstruction project. Actually, currently we are working on. Okay, there is an old apartment in Yeongwol, Gangwon, Korea. Kind of 35-year-old building, kind of old building, so need to be reconstructed, remodeled. So there are only blueprints. Okay, those blueprints. All those blueprints. Actually, color is blue, but because of Photoshop, the color changed. But anyway, totally blue. That is why this one we say blueprints. Anyway, mostly hand-drawn drawings, just plans. So based upon those given information, how to make computational model using AutoCAD plans or SketchUp 3D, 3D Max 3D. We use the building information modeling tools such as Revit and some more applications. So based upon those given existing documents, we build Revit model, even if it's kind of a preliminary design, not detailed design, but it's exactly same dimension to current building, existing building. Okay, modeling to this one, it takes a couple of hours, not very long time. But anyway, based upon this BIM model for existing building, we could do something more plans. What kind of plans? Remodel plans, okay? How to remodel this building? Okay, this is the existing building, and there is one type is making horizontal extensions, okay? Extension to the existing building and vertical extension also possible. And also annex building or some more building, new construction, and connected them together for one building. Total 3 different types of remodel plan we can make. And also there is another thing. Take a look. This is 2 apartment units, okay? One single unit for one family, that was existing building. But for new plan, the building owned by Yeongwol, Gangwon, Korea government, okay? This is government funded project. So this government building planned to be kind of some elderly housing for disabled people, housing for some type of people who need cares by government, something like that, okay? So based upon those BIM models, we could do kind of preliminary structural analysis and some type of design quality assurance and applying several design alternatives, making alternatives, design alternatives. So basic concept diagram is something here. There is an existing building, okay? So given blueprints, we modeled some blueprint-based plan for new type of extension plans. And actually there are 3 or more, even more units. A unit for single person, a unit for 2 persons, something like that, okay? Unit for disabled person, unit for elderly housing, something like that. So unit plan can be separately designed by experts, and they can be loaded to this building model in order to make some design alternatives, okay? So at that time, roughly we generated those extensions, vertical extensions, and some annex building, new construction added, and so on. And also, take a look. I list up only 3 design units, modules. This one for 1 person, okay, 1 single unit, and another unit for 2 person, kind of new married people, something like that. And this one totally separated 3 kind of elderly housing, shared housing, okay? 3 separate private rooms, but shared dining room, shared living room, and so on. So this one for 3. Unit for 1, 2, and 3, okay? So in terms of some type of combinatorial analysis, we simply put 3 different units on 3 different building types. So total 9 different design alternatives can be automatically generated, okay? So this is the design alternative 1. For this building, if we apply the single unit module, and if we apply the module for 2 persons, module for 3 persons shared, and also design alternative 4, series of design alternatives can be auto-generated by BIM application. At this time, we use the Revit. So this plan application and different module for 2 persons, 3 people shared housing, and alternative 7, 8, 9 could be generated like this way, okay? So those series of design alternatives can be populated by these different building types and different building module units. But that's kind of special allocation, design issues. Thanks to BIM, we can use some additional information appended on top of that building model, such as we know the address, geospatial information for this building at Yeongwol, Gangwon, okay? So this precise GIS data can be loaded to this building, and then computer understands the sun's location if we put specific date and time, okay? So thanks to this information, this yellow colored band shows you the movement path of the sun, daylight, okay, daytime, according to its location and kind of compass information. This is so-called solar study, okay, solar study or daylight analysis. And also, computer knows where is the room for private, where is the room for building common, where is the space for shared, and so on. So different color scheme can be displayed even in this building model, as well as some additional application, BIM application for analyzing spatial allocation issues like this. They provide precisely computed area numbers. For example, dining room on the first level in public department could be 7 or 22 square meters, and so on. Very detailed area calculation and analysis can be conducted. That's not the end. Thanks to the building envelope and the weather data for this area, we can preliminary analyze the energy bills, okay? How much cost we need for running this building, 1 year. So entire cost for heating or air cooling can be counted based upon this kind of BIM application. So this report shows you some type of data report according to heating demand, cooling demand, based upon given and existing data of this building geometry as well as weather data. So let's take a look. This is actually the final design alternative we developed together with our research team. So I'm going to show you some details for this kind of BIM-enabled design approach for actual building for this case. This building going to be actually constructed from next month, okay? So this kind of separate views and 3D simplified views, all they auto-generated from BIM application. At this time, it's Revit. So detailed slide link I'm going to show you at the end of this lecture, okay? Okay, let's get back to the issue. The reason why I show you that case is that is kind of new approach, okay? Something different from your design studio work or some design, interior architecture design or architectural design approach, okay? It's not just simply because of different application. It's totally different approach, okay? So let's get started talking about some different approach, BIM. Why we need this BIM, and fundamentally, what is building information modeling, okay? What's different from what you have walked through this semester? Geometric modeling, okay? What's the difference between geometric modeling, CAD and graphics, as this class literally means, and building information modeling, what I put more emphasis on, okay? Okay, in terms of this short timeline of computer-aided design, 1961, MIT Ivan Sutherland's Sketchpad. That is the first computer system, okay, for design. Okay, just 50 years ago, okay, 50 years ago. But in the industry, kind of 40, 30 years, very short history we have compared to the history of design, compared to the history of architecture. Design computing, computer-aided design, CAD systems, 3D systems, its history is really, really shorter than design history. But anyway, how about BIM? Theoretically, we have 30, 40 years history of building information modeling. It's theory and concept, but the application available around only 10 years ago, okay, 15 years ago. That means just nowadays, 10 years, 15 years, the cutting edge technology in our industry, building industry, design industry, this leading cutting edge technology is kind of ground shaking technology. And we need to figure out and we need to take maximum advantages of such cutting edge technology. That's my point for today's lecture, okay? Just 10-year history, 15-year history of this technology going to change almost everything for your future job or future working environment and so on. So this one-page slide, I showed you this one again and again. This semester, we focused on surface-based 3D modeling using 3D Max and mental ray, V-ray renderers. But next semester, we're going to deal with this part, okay? Solid model, parametric model, but they all included in building information modeling tools, such as Revit and some more tools. So let's take a look at what is BIM, okay? Let me show you some series of short videos, okay, from YouTube. So let's take a look at this video first, okay? What is BIM for beginners? This one represented by Graphisoft. Graphisoft is another CAD application developing company based upon Europe. So let's take a look at this video file first. What is BIM for beginners? Very brief and clear introduction and guide for understanding BIM. Okay, I like to bring your attention why we need such kind of advanced or intelligent systems, so-called IT-based technologies, cutting-edge technologies in our domain. Our domain, as I said before, AEC/FM industry, architecture, engineering, construction, as well as facility management industry. Actually, we are working on, especially focusing on interior architecture design. Simply, we are in the department of interior architecture design, one part of architectural design. But anyway, I told you before, again and again, what if your design cannot be realized? That's kind of just drawings or just fine artworks. Our design is supposed to be realized, implemented in real world. So we need to figure out next phase process, such as construction, documentation, as well as long time of maintenance, okay, for the building. So design IT, construction IT, and so on. That's what I'm talking about in our design computing class. And let's take a look at why such technologies we need. So this is a reference from the SciFi, Stanford. Take a look, labor productivity in construction and non-farm industry. So this black line shows you the productivity, okay? So since 1964, this non-farm industry means, how about motor vehicle industry? Ford, GM, or something like GE, or smartphone, computer industry. Their productivity is kind of rising, doubled, okay? Which means by the spending same money, they made 1964, but nowadays, 2009, according to their record, if they spend the same money, they can produce doubled, okay? 2 products, simply say. But take a look, construction industry in gray lines. Nothing changed, okay? No productivity enhanced. Why this one is going up? Simply because of computing technologies, something IT-based, advanced features applied for their fundamental systems. So this is the problem of our industry, AEC/FM industry. So let's take a look at those terms. MIS, Management Information System, ERP, Enterprise Resource Planning, Lean Manufacturing, Six Sigma. You may have heard the name Jack Welch, the president of GE, and human resource, supply chain management, customer relationship management, and so on. What are those things? They are all something innovative approaches for business, okay? You may know those terms if you read some series of related books or some information documents or web documents and so on. Anyway, those are some general efforts in other industry, okay? Business management strategies. Thanks to these approaches, as well as they are mostly based upon some IT-based applications, systems. Thanks to those efforts, their productivity going up and up, now it's doubled, okay? But the problem of our industry, AEC/FM industry, no changes, no rising up in productivity. Simply, IT-based solutions are important to facilitate reducing cost, improving quality. But our industry, what are such efforts? What are such technologies we can use available? Okay, in our industry, they are going to be building information modeling, IPD. IPD means integrated project delivery. The term project here means building project, okay? New building project, new remodel project, new interior design project, and so on. Delivery means simply giving your design, your building products to the owners. So integration means something integrated with design and construction, design and analysis, design and engineering, and so on, okay? So such building information modeling based integration can be supported by IT-based management strategies. In our domain, BIM and IPD or some IT-based design computing technologies are those efforts, okay? That's my point. So in that case, why BIM and IPD we need? Building information modeling or integrated project delivery. Integration means your design studio work supposed to be integrated, combined with next phase process, which means working process for real construction, working process for real manufacturing, and so on, okay? Why we need integration? Why we need IT-based design computing technologies? Okay, simply say, let's take a look at stakeholders. Stakeholders, your design project, your new building project. There are owner groups, okay? Owners, facility users, managers, and also designers, architect, interior designer, structural engineers, and construction managers, contractors, subcontractors, fabricators, manufacturers, schedulers, estimators, and outside organizations, some government agency, financial, insurer, community, even local community people. In general, more than thousands of people going to be involved in new building project, okay? Building remodel project, too many people. If we have very powerful president, powerful ruler for this project, we don't have problem, right? But that's not possible. We have to reconcile different people's different opinion, their rights, their demands. We need to take care of all the demands, okay, from different parties in order to make our building realized without any problem. That's the point. So let's take a look at this simplified building life cycle. Building life cycle is another very important thing we need to take care of, okay? Feasibility study and design. We need to roughly visualize our concepts and approaches and develop the design for construction, planning, documentation, some details, and then actual construction. After as-built, operation, maintenance, management, until the building demolished, okay? This is one single simplified life cycle of building, but probably this one can be lasting 100 years, 200 years, or just 30 years. But anyway, the most important thing is operation and management is kind of long period, but others, especially design, comparatively not that long, okay? We need something advanced intelligent technologies and data information for managing this life cycle in an integrated way, okay? Simply for reducing cost and enhancing quality, okay? Maximize the effect. BIM, as it literally means information modeling. So let's take a look at some formal definitions, formal description about the BIM, okay? BIM is a model plus database. So what is model? What if you have SketchUp model, 3D Max model, AutoCAD model? That's going to be geometric shape of the building, but you have database. Database means any type of data or information you need for that building, okay? This simple phrase is, I think it's very good definition, very good description about building defined by American Institute of Architects, AIA, okay? Another one, the kind of father of BIM, my former advisor, Professor Chuck Eastman, coined this term, BIM is a process, okay? It's not just single model or static model, it's a process. But actually this one is, I think, kind of long version and very informative definition about BIM. It is a digital representation, okay, of physical and functional characteristics of a building, of a facility. As such, it serves as a shared knowledge resource for information about a facility, forming a reliable basis for decisions during its life cycle, okay? Life cycle is a very important term, building life cycle. It's not going to focus only on design phase or construction phase, okay? It handles entire process. Entire process means building life cycle, okay? So this is visualized building life cycle from design to demolition for the building. So what you are focusing on now is design visualization by using rendering tools or style tools, 3D modeling tools, SketchUp, AutoCAD, Rhino, 3D Max, and so on, okay? But actually we need this kind of documents, specification documents, series of detailed drawings and some analysis, simulation, and lots of construction and operation related information actually we need. Building life cycle is important, critical. Even if now we are working on only for design and design visualization, we need to take care of what is the next phase issues, what's the topic in this regard, okay? Let's take a look at this information value diagram, information value by time, okay? So in planning, we don't have anything. We have just demand, okay? Okay, now we're gonna design a new building. So we build some information. But how about design phase? We need to hire someone who's in charge of designing building. So some missing information. Designers, architect firms, whatever it is, they going to design and accumulate their information. But in construction phase, construction company going to be in charge of some construction documentation and planning and so on. So another missing information. After as-built, after construction, now it's time for management, operation. But operators cannot acquire entire information set from construction company, okay? That's as usual. So amount of information waste, okay? What if we can accumulate information and data for building lifecycle data from the beginning of the project, okay? That's my point. We need to accumulate seamless information collection regarding building lifecycle, okay? That's the main goal of integration using building information modeling. Another diagram, this one is McLemie curve. McLemie is the former CEO of famous worldwide design firm named HOK, okay? So pre-design phase, schematic design, design development, construction documents, bidding, and construction phase. Let's take a look at the line, gray, number 2, cost of design changes. Of course, at the beginning of the design, whatever we do, that's going to be our design, our plan. But what if we have design changes in construction phase? That's going to be really expensive, okay? We have to change lots of things. It costs lots of money, time, human resources, and so on. Waste, okay? Take a look, this black line, number 3, traditional design process. The collection of design effort and design effect going to be built in construction document phase. What if we can make this one earlier? Number 4 is ideal. Okay? Even in early phase of design, for your concept design and schematic design level, we can collect amount of information we need for rest of building life cycle. That's the goal of building information modeling as well as integration, integrated project delivery. Okay? So if we can acquire the information we need before we use them, and then that's going to be really powerful. Okay? So actually there is another issue. I told you thousands of people is going to be involved in building project. You can be one of them, okay, as an interior designer or as a planner, as an architect, okay, or even engineers. So what if we use SketchUp? What if architects use AutoCAD? Constructors or engineers use totally different applications, different information set. File exchange, information exchange, data exchange, that's going to be really big problem as always, okay? But this one is open BIM based approach. Open BIM means shareable, interoperable, BIM enabled approach for interoperability. Okay, so let's take a look at this another video file. Okay, another short video from YouTube to explain you why this kind of information share and data exchange is really critical thanks to BIM. Okay, let's take a look at this video. Okay, Open BIM is kind of internationally managed type of, simply say, a file type. Now it's the file is IFC. So Building Smart International. I'm working on for that organization for maintaining kind of neutral and interoperable files in BIM domain anyway, actually. Okay, building life cycle. I told you building life cycle is very critical for understanding and figuring out our building project, not simply focusing on interior architecture design or interior design, decoration. Anyway, let's briefly take a look building life cycle, okay? Feasibility study as required and design as designed, and the construction planning as planned in order to make some construction process, actual construction process on site and as built, and then long time for operation and management, okay? But I like to anyway bring you another attention to new features of building life cycle. FM, okay, facility management. What is facility management? Okay, we are in interior architecture design. So your design studio work, possibly some existing buildings remodel project that I show you today's case study, and your design studio work can be done in existing building or even new building anyway. So interior architecture or interior design, decoration, such jobs, possibly one part of facility management, okay? Not new civil project or new building project. So in terms of that building life cycle, I like to show you another brief video, building life cycle and facility management. So what's the concept of facility management? Let's take a look at this another video. Wake up, okay? And then have a break, move on, okay? Let's take a look at this video and figure out what is FM and how to handle that kind of issues. This is Autodesk video, actually kind of commercial ad, so focusing on Autodesk products. But anyway, let's take a look at how to manage building lifecycle in terms of FM. Okay, actually this was kind of commercial video from Autodesk, so they focused on their product software. But anyway, we need to carefully take a more look on FM issues, simply because, take a look, 100 years of building management, how many remodel, how many interior design projects can be done, okay, based upon that 100 year ago new building project. So we need to carefully look at some even more things in terms of building life cycle, as well as facility management. So let's walk through the process one by one briefly after the break. Okay, let's get back to the course material. Let's briefly take a look at the building life cycle, okay? From the beginning, feasibility study and design. But actually, feasibility study, there are a bunch of design requirements, such as design guide, building code, fire code, and so on. But okay, let me skip this part. But let's take a look at design phase. What's major difference from geometric modeling in your general design studio course with BIM-enabled, BIM-based design? It's one salient case is space object-based design, even in early phase of design, okay? So we are not going to handle space object when you are working on AutoCAD or SketchUp, even 3D Max. There is no such object. If you build walls, floors, columns, furniture, and then rest of void space is going to be space object, okay? You believed as a space, not real space object. But in BIM model, we can make some mass model-based structure using simple geometry. And take a look at this case. They are collection of space objects, okay? Space for corridors, toilets, office area. And then we can separate different use of spaces. At the end, this is Revit interface, okay? Those lines are boundary of the space objects. They are not 2D drawings, 2D floor plans. They are kind of auto-generated 2D views, okay? Totally based upon the scenario, the plan of your space allocation. So this is one big different part of building information modeling from geometric oriented modeling. So let's take a look at this drawing. If you draw something like this, you may recognize this is one of the space. In geometric modeling tool, if you put label named office, okay, now this is kind of office area. But in AutoCAD, it's just label text, okay? And it has layer, 2D, even 3D, just a geometric model. That is CAD drawing. But if you build in 3D BIM model, this is room object, okay, in Revit. In Revit, in BIM tools, you have to assign space or a room object. That's one big different things. And your room name is office, not label, okay? Room's name property is office. Department name, space number, area, height, spatial relationship, they all defined in BIM model, okay? That's the change from geometric model, CAD model to BIM model. Even more information you can assign, lots of more information as a database for building, design, construction, maintenance, management, and so on, okay? That's the big change of BIM from geometric model. This is 3D Max model, SketchUp model, AutoCAD, Rhino models. But this is Revit or other type of BIM models. Really big difference you need to find out. Design quality assurance by using BIM. From now on, how to use information we have. This is one of the BIM application. Based upon this one, in 3D, we can analyze space allocation, area calculation, architectural program, and so on. How about this one? Circulation analysis. This kind, blue lines are circulation paths between those two spaces and another space. Carefully and automatically measured working distance, number of tons, how many spaces we have to passing by, they all computed in automation in order to make this building design better, okay, as a data set, as an application. Let's take a look at one of the case study. Around 10 years ago, 8 years ago, when I was in Georgia Tech, we conducted US federal government, GSA's courthouse design automation project. At that time, by using BIM model, we analyzed space program, circulation, security, energy, and preliminary cost estimate in automation for enhancing their courthouse design quality. Okay, this is one of the representative BIM application, BIM project. Take a look this Excel file. This one shows you space program review, information data set. This Excel file is auto-generated, okay, not human-created Excel file. This is auto-generated from BIM model. Area calculation, number of courtroom, building efficiency, lots of information we need to know, auto-calculated and displayed, okay? So circulation analysis purposes, those graphs and circulation representation all evaluated before construction in design phase, okay? As one of the example, let me show you this case, okay? This is Autodesk website. When I was in Autodesk Idea Studio as a researcher, okay, let's take a look this one. Implementing better language on Revit architecture. So this project, resident Jinguk Lee completed PhD at Georgia Tech, advised by Eastman, recently joined Hanyang University, Seoul, Korea, and as a professor and teaching BIM and design computing courses using AutoCAD 3D Max Revit. Okay, so next semester you're gonna get some Revit and more BIM applications. But in reality, even in this semester, we are dealing with 3D Max, Mentalway, SketchUp, AutoCAD, and so on. But anyway, let's take a look at this brief video file quickly, okay? That's one of the examples in order to facilitate given BIM models as an information set, okay? So there is different type of awards named BIM Award. Let me show you two student work. Those two design panels are looking like very typical design competition panels, but they are totally BIM-based project, okay? The building design, analysis, solar study, energy calculation, visualization, renderings, all done by BIM applications, probably Revit, and this one too, okay? Various floor plan generation, auto generation of drawings, plans, as well as some mass study, solar study, and some realistic visualizations. But those two have done by students, and those two example cases done by professional architect firm. This one, actual building for Gangwon, Korea. Take a look, this building design. This is award winning in design competition, and this building now under construction. Anyway, thanks to BIM application, from the beginning of the project and end of kind of design project for next phase construction issues, this one contains amount of information in terms of building life cycle, focusing on, just their focus was on design. One of the reason I picked up this one is take a look this part, okay? Some plans in interior. So in terms of interior design, interior architecture design issues, they also used some interior facility libraries. They established their own library for furniture, partitions, and some other additional facilities. And they design those components in order to create some auditorium, main lobby, or some CEO's office. They all represented and designed by given BIM environment, okay, BIM tools, not 3D Max, SketchUp, AutoCAD model. They simply load this library and allocate, layout the design. And take a look, the rendering output, all done by BIM tools at this time, Revit. This is mental based photorealistic rendering. You don't need to take care of additional things. All lightings, materials given from library and its environment. Okay, construction, documentation, and actual construction. There are a amount of issues: structural design, structural analysis, engineering issues, mechanical, electrical, plumbing, heating, ventilation, air conditioning, facilities, systems, details. But actually, they are kind of sort of out of scope, and you are second year student. So I have a bunch of demonstration videos and tutorials, but let me skip this part, okay, construction part. Instead, I like to show you one of the example, what I focused on, facility management issue, okay? So let me show you one case study in terms of facility management using BIM and smart devices. I mean some design computing tools, hardwares. MGH means Maryland General Hospital, okay? Maryland General Hospital kind of remodel project, extension project done by BIM and even more advanced technologies. And let's take a look this one. This is Maryland Hospital, Maryland General Hospital, BIM model and actual building, okay, after the remodel. So this is hospital, really complicated facilities, mechanical systems. So how to maintain, how to manage such facilities? So they use this kind of smart handheld devices. The site workers measure the on-site facility using this kind of barcode system, and then their BIM models auto-synced, updated, and managed for their several BIM applications, design computing technologies, okay? So this is the final video, a short video. Let's take a look at this case, okay? This barcode means some piping, pumping, or facilities behind this ceiling facility. We can simply scan this barcode and measure the meters or some other information in order to sync the data collected by this facility into BIM model, computational model. Of course, this one can be auto-sync by Wi-Fi, Bluetooth, any other advanced technologies. But anyway, my point here is building information modeling or even additional design computing technologies such as IT systems, smartphones, handheld devices, your smart tablets. That is the tool that we can no longer afford not to have, okay? Driscoll coined this phrase, okay? So actually this was really kind of critical for your near future job because you are a second year student, so we need to take more accounts on something advanced, something intelligent, and newer way of our domain, environment, okay? That's going to be design computing technologies. I just showed you one tiny snippet of our new challenging environments, but anyway, we're gonna get more developments in the future, okay? Okay, let's finish the lecture and then move on to the next issues.